Hi, today we are going to see the past paper question of electrolysis of aluminium oxide. Yeah. The aluminium is extracted by the electrolysis of molten mixture that contains alumina, which is aluminium oxide. So alumina is nothing but aluminium oxide, Al2O3, right? Okay. So over here, the ore of aluminium is bauxite. Ore of aluminium is bauxite. Bauxite is again, what is it? Impure aluminium oxide. Impure Al2O3, right? So here this contains alumina, which is amphoteric. Amphoteric, very important clue they have given here. Amphoteric in the sense, alumina is the oxide of aluminium, which is a metal oxide, right? Oxides of metals are always what? Basic, right? Oxides of metals are always basic. Oxides of metals. Oxides of all the metals are basic. But aluminium oxide, what they are saying, it is an amphoteric oxide. That means, so over here, amphoteric oxides, we have seen a list of amphoteric oxides, right? So, what are amphoteric oxides? In metal chapter, you might have learned this. Amphoteric oxides are aluminium oxide, lead oxide, and what is it? A zinc oxide. Yeah. So all these three oxides are amphoteric oxides. Amphoteric means which can react with acid as well as base. So if you see this question, the ore of aluminium is bauxite. This contains alumina, which means I said impure aluminium oxide, right? That means it contains alumina, which is amphoteric, and iron oxide, which is the impure substance in it, which is basic, because iron oxide is what? Oxide of metal, which is basic. So the ore is heated with aqueous sodium hydroxide. Sodium hydroxide is what? Alkali, a base. So a base cannot react with base, and a base cannot react with alkali, but amphoteric can react with alkali, right? Because amphoteric can react with acid as well as base. But when you take a base, oxide of a metal, it can react with acid as a neutralization reaction, but not with base. So the dash dissolves to give a solution of dash. So what reacts here? Which reacts here? Aluminium oxide reacts here. Al2O3 reacts here, which dissolves in a solution of, so the aluminium oxide dissolves to give a solution of sodium aluminate, because it reacts with sodium. It dissolves in sodium hydroxide. You get sodium aluminate. Got it? Sodium aluminate. Then which does not dissolve here? Just now we have seen iron oxide, which is just a base, cannot react with again with another base, with alcohol. So iron 3 oxide. Iron 3 oxide, what they haven't asked formula here, but still, what is the formula for iron oxide? Iron 3 oxide, 3 is the oxidation number, Roman number 3. That means Fe is what? 3 plus. Oxygen is what? 2 minus, since it is sixth group element, right? So by crisscross, you can find the formula Fe2O3, right? So Fe2, iron 3 oxide, Fe2O3 does not dissolve, and it can be removed by filtration. If something does not dissolve in it, in the sense, you can remove this by filtration, right? Yeah. So I'll give you the formula again. They haven't asked here, but I'm giving you to know. Sodium aluminate. What is the formula? NaAlO2. Sodium aluminate. O is 2 minus 2O, that means 4 minus, and aluminium 3 plus, sodium plus 1. So oxidation number. Sum of oxidation number will be 0, right? Okay. Then come to the next question. What is the next question here? Complete the labeling of the diagram. Okay. So what is it? This is carbon anode. Then we have learned that aluminium deposits, the molten aluminium deposits in the bottom. The reason is the steel that apparatus, like the steel container, which is coated with carbon. So that means what is it? A carbon cathode, minus in the sense cathode, right? That's why cation, aluminium ion is cation, which moves towards cathode, right? Okay, what is this then? Mixture of aluminium oxide and what? So it is aluminium oxide, molten aluminium oxide. But along with it, we are adding something. What is that? Molten cryolite. So for what purpose we are adding molten cryolite? Molten cryolite decreases the temperature, as well as it lowers the melting point of aluminium. It saves energy. Very important question. In many past paper question, you can see the uses of cryolite, right? Okay. So over here, what is settled here? What is settled here? Aluminium, molten aluminium, right? Molten aluminium. Okay. What is the temperature? So if there is no cryolite, the temperature will be 2000 degrees Celsius. But here we have added molten cryolite, so the temperature reduces to 2000 degrees Celsius to between 800 degrees Celsius to 1000 degrees Celsius, right? Okay. Then, so what is the next question? Okay, these are all like continuous questions. One single question we are saying. Okay, the ions that are involved in the electrolysis of aluminium 3 plus and O2 minus. Write an equation for the reaction at cathode. So we know cation moves towards cathode. Cation is aluminium ion. So aluminium ion is Al Al3 plus, which has to come on top, right? Yeah. Okay. Yeah. By mistake. Al3 plus gains 3 electrons. Okay. To become Al. Am I right? Yeah. So while balancing, like if you know the overall equation, then you will not write like this. So what is overall equation? Aluminium oxide Al2O3 decomposes to aluminium ion and oxygen ion. There you get 4 aluminium because 2 Al2O3, which leads to 4 aluminium and 3 O2. Because if only O3, oxygen, you cannot write as a diatomic molecule. So that's why we made it into 2 moles. So 2 moles of aluminium oxide leads to 4 aluminium and 3 O2. Now think of here. So 4 aluminium ion, that means 4 into 3, 12 electrons. So change this 12 electrons, which leads to 4 aluminium. You can write like this also, right? Next, explain how carbon dioxide is formed at the anode. Okay, we know oxygen moves towards carbon anode, but over there the carbon which is present in the anode reacts with oxygen, which forms carbon dioxide. Okay, and it goes as a waste gas. Okay, that is it. And then continuous question, like 16 mark, one single question for 16 marks. Remember how important it is. So give an explanation for each of the following. Aluminium is used extensively in the manufacture of aircraft. So what? Which property made it to react over here? Because it is less denser or less weight. Okay, less weight. So because less weight. less heavier than other metals, right? Or less denser. Okay, less denser. Okay. Then aluminium is used to make food containers. Why? Two marks. Two marks in the sense here. It is aluminium is malleable and ductile. That is one of the reason. And the other reason is which forms aluminium oxide layer. So aluminium oxide layer, which is the protective layer. Okay, which is a protective layer which protects the remaining aluminium to react with the food. Okay, so this aluminium layer which is present in aluminium, which protects aluminium to react with food, so which is safe to use as the food containers. Okay, aluminium electricity cables have a steel core in it. What is the purpose? So if you write steel is a good conductor of electricity, you lose your mark. Okay. So here you have to write to strengthen this. Okay. For strength. For strength only, we are using steel core in aluminium. Okay. Yeah. So you'll get, if you write like this, you get 16 out of 16. Yeah. Thanks for watching, children. Bye-bye.